Assalamualaikum. Today we are from Bmmd 1/2. We'll present about the assignment Design Machine Element, Gearbox. First of all, I would like to introduce our team members. First team member is me myself, Muhammad Haikal bin Hishamudin. Second team member is Muhammad Nazhif bin Yusri. Third team member is Ahmad Haikal bin Muhammad Nasir. And the last team member is Muhammad Syakir Asyraf bin Nordin. First, I would like to tell the introduction about this assignment. In this assignment, Gearbox is the good existing machine which have the several machine element, which is gear, bearing and shaft. It is the great opportunity to study about the concept and the function of this gearbox. The gearbox is a mechanical device used to increase the output torque or to change the speed of a motor.
Element and functions. First is a worm gear and material is steel, and the function is to convert the rotate motion of the worm into perpendicular motions. And the second is shaft and worm gear and my steel material, and the function of the shaft and worm gear is rotate and transmit a power of driving device. And lastly is shaft and my steel material, and function is to hold it its place and prevent to move during the operations.
Hi, my name is Muhammad Nazir bin Yusri from Bmmd Section 2, and I will show you the exploded view of our gearbox. As you can see, this is the exploded view of the gearbox, and you can see the inner side for the parts in the gearbox. Next, this is video for exploded and collapsed view of our gearbox. Next, this is the bill of materials for our gearbox design. There are a total of 9 different parts in the gearbox. All the parts are listed in the table of bill of material.
For finite element analysis, this is where we utilize the SolidWorks simulation to analyze the machine element. So this is the simulation for worm gear shaft. This is the simulation of the shaft. And last but not least, this is the simulation for worm gear. The four possible failure: fatigue fracture is due to pure design, incorrect assembly and overloads. Then, for impact fracture is normally due to inadequate use specification and misuse during operation. Furthermore, gear wear may happen because of moderate wear and tear, frosting and abrasive. Last but not least, stress rupture were caused by oxidation and phase change. For proposed solution, proper gear material selection, heat treatment and lubrication are crucial to minimize gear failure. Selecting appropriate shaft materials, optimizing shaft dimensions and ensuring proper alignment and bearing support can help prevent shaft failures. Design optimization to reduce stress concentration, improve tooth profile and enhance gear machine also can be considered.
In summarize, the analysis of a gearbox release the significance of a material selection, geometry design and optimization, function understanding and failure analysis. Finite element analysis (FEA) aids determine optimal design and material, leads to improve the strength, reduce the friction and increase the lifespan. The function of the diagram implies the importance of input and output shaft, gear, bearing, housing, and the lubrication system in power transmission and smooth operations. Considering the potential failure modes like gear tools, brakes, bearing fueler and shaft fueler are secure of ensure gearbox reliability. Design modification, properties, lubrication, and maintenance practice can mitigate their fueler and enhance performance by taking a comprehensive approach to material design, function, and fuel analysis. Engineer can create robots and efficient gearbox suitable for variation applications.